Next, in the continuation of the class, in the electrochemistry point of view. So in the next equation point of view, we are calculating the first one, E0 cell. How to calculate the E0 cell? Right, standard reduction potentials values. Right, standard reduction potential of the cell. Then we can go for the E cell from the next equation point of view. So in the continuation of the last class, we already discussed and explained some of the examples in the how to calculate the E0 cell. And another one example, suppose if it is given E0 of zinc plus 2 to zinc minus 0.76 volts, E0 of H plus is going to be H2 gas, half equivalent of H2 gas is 0 volts. 0 volts. What is E0 cell? When E0 cell is equal, here it is 2 electrodes which is given and standard electrode potentials values will be given. Standard electrode potential values, E0 values will be given. Standard electrode potential values at 25 degrees centigrade, 1 molar concentration. So, the electrode potential is standard electrode potential. Already we had discussion takes place in the last class. Now, based on this, how to calculate this? E0 of cathode minus E0 of anode, or E0 of right minus E0 of left. So based on this, our highest reduction potential minus highest standard reduction potential minus lowest standard reduction potential values. Now, or this is act as cathode. Highest reduction potential if is there, act as cathode. Lowest reduction potential is act as anode. At highest reduction potential case, which one it may be takes place? Cathode reduction takes place. At anode, oxidation takes place. Now here it is 0 volt is there. So here in this case, this is more compared to this 0 volt is more. This is negative sign is there, right? It is lower value. So 0 is greater than to the minus 0.76. It is less than 0. So here it is which one? Acts as cathode. Which one takes place? Reduction. Here it is acts as anode. Which one takes place? Oxidation. And E cathode minus E anode. This one minus this one, or when the highest reduction potential is there, act as cathode, lowest reduction potential act as the highest reduction potential minus lowest reduction potential. How much is there? Highest is 0 volt minus, how much is there? Minus of minus 76. So how much is there? Minus into minus is plus, that means 0.76 volts. 0.76 volts. This is one of the example. Suppose another one, E0 of Cu plus to Cu is minus 0.34 volts and E0 of Ag plus Ag is, or Fe plus to Fe, anyone you can, this combination already suppose we are discussing takes place. What is E0 cell? What is E0 cell? This example. How much E0 cell? So now first, whether if it is given the values, standard reduction potential values is given or not. Standard reduction potential values are mentioned or not. See, listen, this Fe plus 2 is going to be Fe. This is reduction reaction takes place. Fe plus 2 L taking 2 electrons, Fe reduction reaction. This potential is standard reduction potential. Now this potential is standard reduction potential or not? No, this is oxidation potential because C is going to be Ce plus 2. This one is given as which one? Standard oxidation potential. Standard oxidation potential. This standard oxidation potential is converted to the standard reduction potential. How? By putting the minus charge. By putting the minus charge. That means this E0 of Cu plus 2 Cu, that means E0 of Cu plus 2, this is oxidation potential. This is conversion to the reduction potential. How? By putting the minus charge. By putting the minus charge. Here it is placed at the minus charge, then this one is converted to the reduction potential. First this is oxidation potential is given, then this is converted to the reduction potential. So how much it may be there? Reduction potential is minus of minus 0.34. So this is minus 0.34 is the oxidation potential, then which one it may be there. So this is converted to the reduction potential. Now both are reduction potentials. You compare the which one is higher reduction potential, which one is lower reduction potential. That means E0 of Cu plus to Ce is how much? Then 0.34. After then conversion takes place, 0.34. Then this one is Fe plus 2 to Fe. Already this is reduction potential minus 0.44 volts. Which one is more? This one is more compared to this. This is negative sign. So which one acts as cathode? What is takes place? Reduction reaction takes place. This is acts as anode. Which one it may be takes place? Oxidation takes place. Right? So more reduction potential, reduction, acts as cathode. Less reduction potential, acts as anode. Both are reduction potentials. So now E0 cell is equal to how much? Highest reduction potential minus lowest reduction potential. How much it is there? 0.34 plus 0.74. 0.34 plus 0.74 is 0.78 volts. 0.78 volts. Like this it may be there. Alright. And another one more, like this similar type of examples. E0 of zinc plus 2 to zinc minus 0.76 volt. This is reduction potential because reduction reaction is given. Zinc plus 2 while taking the 2 electrons going to be zinc. That is taking the electrons, receiving the electron, that is reduction process. Already I have explained that clearly in the last class. So this is reduction potential. And another one, Mg plus 2 to Mg magnesium. This is also reduction reaction. Magnesium plus 2 while taking the 2 electrons. So both will be given the reduction potential, standard reduction potential values to minus 2.3 volts. Now which one value is more? In these two values, this value is more. Minus 0.76, which is closer to the 0 compared to this. This is less value, this is more value. Right? So this is more and this is less. So more reduction potential minus less reduction potential. So E0 cell is equal higher reduction potential, higher standard reduction potential. So minus 0.76 minus lower standard reduction potential. Minus 2.3. So how much it is there? Minus 0.76 minus into minus is plus 2.3. How much it is there? So nearly this is 1. Here it is 54 volts approximately. So 1.54 volts. Right? So this is happening here in this case in the E0 cell. So how to calculate the E0 cell? So like in this manner you can calculate the E0 cell. Right? So higher reduction potential minus lower reduction parts, you can check both values will be given as the reduction potentials or not. So if it is both are reduction potentials, then you go for that higher reduction potential minus lower reduction potential. If it is not given, you can convert that oxidation potential to the reduction potential. Then you can apply the higher reduction potential minus lower reduction potential, or E cathode minus E anode, or E right minus E left, because right side reduction reaction takes place. Considering the cell notation, left side it may be oxidation reaction takes place in the cell notation place according to the salt bridge. Right. Next one, similar one, some problems we have seen. Right. Some concept again. I am explaining some more concept. See, listen. If a reaction is given, suppose which of the following is correct statement? Which of the following is correct statement? Which of the following is correct statement? Option A. So which of the following is correct statement? Which will be given E0 of zinc plus 2 to zinc minus 0.76 volt, and E0 of Cu plus to Cu 0.34 ounce. 0.34 ounce. So option A is given. Which one? Zinc oxidizes copper. Zinc plus 2 oxidizes copper. Copper oxidizes zinc plus 2, and Cu plus 2 oxidizes zinc. Which one is the correct reaction? Sometimes 2 marks questions will be given in rare cases, but although sometimes it may be happen. So that's what I can explain, right? So which one it may be? This fundamental one, very fundamental one. So now based on these two reduction potentials, which one is more reduction potential? Cu plus 2, Cu plus 2 Cu is more reduction potential. Both are reduction potentials, definitely, right? Reduction reactions will be given. So higher reduction potential is this one. And when higher reduction potential is, what will be going to take place? Reduction reaction. So plus 2 charge is there while taking the 2 electrons is going to be Cu deposited as copper solid. Next, less reduction potential. This is less reduction potential. Less reduction potential is going to be takes place. Which one? Oxidation. So which one is going to be oxidation takes place? Zinc is going to be zinc plus 2 electrons. This is solid, neutral form. Now what will happen? The total reaction is what? Zinc plus 2, zinc plus Cu plus 2 is going to be zinc plus 2 plus Cu. This is happened, right? So this reaction, from here in this reaction, what will be given? What will be given? So zinc reduces Cu plus 2 to Cu, one case, and another one, zinc reduces Cu plus 2 to Cu. Next, Cu plus 2 oxidizes zinc to zinc plus 2. Cu plus 2 what doing? Cu plus 2 oxidizes zinc to zinc plus 2. This is oxidation reaction. And Cu plus 2 oxidizes zinc to zinc plus 2. Then zinc reduces Cu plus 2 to Cu because this is reduction reaction. So which one it may be there? Zinc oxidizes Cu? No. Cu plus 2 it may be there. Reduction process case. So that's what another. Zinc plus 2 oxidizes Cu? No. Zinc plus 2 reduces. So next, copper oxidizes zinc plus 2? No. Cu plus 2 oxidizes zinc. So this is not correct one. Cu plus 2 oxidizes zinc, it is correct one. Cu plus 2 oxidizes zinc to zinc plus 2. Right? This is the reaction. This is the statement. Next, another one for similar like this. Which of the following one is correct one? Which of the following is correct one? Which of the following is correct statement? For which one statements E0 of Mg plus 2 Mg is going to be minus 0.23 volts, and E0 of nickel plus 2 nickel is minus 0.25 volts. Minus 0.25 volts. So what will be happen here in this reaction? So you can imagine the statements. Which statement it may be given? Suppose whatever the statements which will be given. So the statements which is mentioned like nickel plus 2 reduces magnesium. Next, nickel reduces magnesium plus 2. Nickel reduces magnesium plus 2. Magnesium reduces nickel plus 2. Magnesium reduces nickel plus 2. Magnesium oxidizes nickel plus 2. Which one is the correct statement? So based on these two, both are reduction potentials directly. So this is the highest reduction potential compared to this. So this is the highest reduction potential. Highest reduction potential is going to be what? Reduction reaction takes place. So while they're taking 2 electrons, is going to be nickel. And lowest reduction potential is going to be oxidation takes place. Which one it may be there? Magnesium is going to be magnesium plus 2 while taking 2 electrons. So while releasing 2 electrons. So which one reaction takes place? Magnesium plus nickel plus 2 is going to be magnesium plus 2 plus nickel. What will happen from the statements? Magnesium reduces nickel plus 2 to nickel. One is there, one sentence is there. And nickel plus 2 oxidizes magnesium to magnesium plus 2. So nickel plus 2 reduces is mentioned. So these two will be not right. Nickel plus 2 oxidizes magnesium to magnesium plus 2, right? So that is not mentioned anyone in these cases. So which one is mentioned? Magnesium reduces nickel plus 2 to nickel. So this one is the correct statement, right? So this type of questions will be there. And in another one more similar type. Which of the following one is correct statement? Which of the following one is correct statement? Which of the following? You may also write the question. Which of the following one is correct? A correct statement. First one. E0 of the statement is, the data is given. CD plus 2 to CD, cadmium, minus 0.40 volts. Next, magnesium plus 2 to magnesium, minus 0.23 volt. And E0 of nickel plus 2 to nickel, minus 0.25 volts. Minus 0.25 volts. This statement is which one? Magnesium oxidizes nickel B. Magnesium reduces nickel plus 2. C. Nickel reduces cadmium. D. Cadmium reduces nickel. Which one is the correct statement? Which of the following one is the correct statement? The given data, right? So how can you calculate the given data? So you write that reactions. So first you can compare the standard reduction potential values is given or not. First you can check them. So the given values are standard reduction potentials are not. So that means here it is M plus N is going to be M. That type is there or not. So all it may be similar like this. So all values are given values are standard reduction potential values. No problem. All the values are standard reduction potential values. So in the standard reduction potential values, based on that, which one is higher, which one is lower, you can compare that. So because higher reduction potential is there, reduction reaction takes place. Lower reduction potential, oxidation takes place. But here in this case, 3 values is mentioned. 3 values is mentioned. So now that, see, total reaction, how can you write that? See, listen. From this, suppose if it is equation 1, equation 2, suppose. From these equations 1 and 2, which one you can compare takes place, 1 and 2. In 1 and 2, which one value is more? This value is more. Cadmium plus 2 to cadmium value is more. That means highest reduction potential is this compared to this when these two. Highest reduction potential is more. Highest reduction potential is going to be which one? Reduction reaction takes place. That means CD plus 2 going to be cadmium while taking that 2 electrons. I can write the reaction. Directly I am writing the reaction. final reaction. CD plus 2 electrons taking takes place CD. And lowest reduction reaction is which one? Lowest reduction potential is this one. Compared to these two, standard reduction potential, lowest standard reduction potential, this one is going to be oxidation takes place. When it is going to be oxidation takes place means which one? Magnesium going to be magnesium plus 2 while taking the 2 electrons. So if we can write the reaction from these two, first two, magnesium going to be magnesium plus 2 electrons, cadmium going to cadmium plus 2 while taking the 2 electrons to cadmium. So if it is 2 electrons is cancellation takes place, this similar reaction it may be there. So magnesium going to be magnesium plus 2, cadmium plus 2 to cadmium. One is reduction, another one is oxidation. Right, this is the first and second reaction. Next another one. From the second and third equations, these two. Which one is the more value? Nickel plus 2 is the more value. So these two cases, in these two. Second and third. So this is highest value. Highest value is going to be which one takes place? A reduction reaction. Higher standard reduction potential is going to be a reduction reaction. So that means nickel plus 2 electrons is taking nickel. I have not mentioned 2 electrons means finally that is cancellation takes place. So that's what I can write the total reaction. So no need to waste the time because in the examination point of view. Next. This one is lowest reduction potential compared to this, then it is going to be oxidation takes place. So which one is the oxidation takes place? Magnesium to be magnesium plus 2. This is one. Suppose from the first and third reactions, you can compare these three, this one, first one and third one. First one is what? Minus 0.40. This is minus 0.25. Which one value is more? Minus 0.25 is more. So that's why nickel plus 2 is reduction reaction takes place while comparing the cadmium plus 2 because this is lower reduction potential compared to that nickel plus 2. So this is oxidation takes place. So that means cadmium is going to be which one takes place? Cadmium plus 2. Now, which of the following statements will be correct? The first statement is what? From this first statement, cadmium plus 2 oxidizes magnesium to magnesium plus 2. Right? So this is not there. So magnesium is going to be reduces CD plus 2 to CD. It is also not there. Next, magnesium reduces nickel plus 2 to nickel. So this is there. Magnesium reduces nickel plus 2 to nickel plus 2. And nickel plus 2 oxidizes magnesium. Is there, is not there. Next, cadmium reduces nickel plus 2 to nickel. Cadmium reduces not nickel, nickel plus 2 if it is there, correct, not nickel, nickel plus 2. So that's why this is not correct one. So next, nickel plus 2 oxidizes cadmium to cadmium plus 2. Is not there. So option second is the correct one from these statements. Or you don't write the relations also sometimes based on the given values, based on the given data. So whatever that higher standard reduction potential value is there, higher standard reduction potential or more standard reduction potential value is there comparing the data. Higher standard reduction potential value is there. Oxidizes, that is oxidizes lower standard reduction potentials. That means this nickel plus 2 is there. Nickel plus 2, this is the more. Compare the following these three data. Which one is more? Minus 0.25 is more. So this nickel plus 2 is higher reduction potential. This nickel plus 2 oxidizes cadmium to cadmium plus 2 and magnesium to magnesium plus 2. Last two reactions is similar like that. So highest reduction potential oxidizes lower reduction potentials. Next, when lower reduction potential is there, lower standard reduction potential is there, that will be reduces higher standard reduction potential values. So that means which one value is low? Magnesium plus 2 is low in out of these three cases. Then magnesium, this one is more. So magnesium, this is less value. This is less value means what? So magnesium is oxidation takes place, magnesium to magnesium plus 2, right? So that means magnesium is reduces Cd plus 2 to Cu and nickel plus 2 to nickel. Magnesium is reduces Cu plus Cd plus 2 to Cd and magnesium reduces nickel plus 2 to nickel. So lower standard reduction potential reduces higher standard reduction potential, and higher standard reduction potential oxidizes lower standard reduction potential. Right? So this is enough data is there from this type of reactions will be given, suppose in examination point of view. Based on that data you can say anyone it may be given, right? Anyone if it is given you can easily calculate it. Next another one more question, right? Next one problem is standard reduction. You may also write the problem. Standard reduction potential of zinc. Standard reduction potential of zinc is minus 0.76 volts. Is minus 0.76 volts. Minus 0.76 volts. Calculate reduction potential of zinc in 0.1 molar zinc sulfate solution. 0.1 molar zinc sulfate solution. So you read that problem once again. What will be given, which one you have to calculate. That is important in any problematic point of in physical chemistry particularly. You read that problem just first, right, and apply the concept. What mentioned that standard reduction potential of zinc is minus 0.76 volt. So which one? E0 of zinc plus 2 zinc is given minus 0.76 volt. Only one value is given. And calculate reduction potential of zinc in 0.1 molar zinc sulfate solution. So reduction potential means E of zinc plus 2 is going to be zinc. This is what? Reduction potential is what? Reduction potential is what? How much? Reduction potential of zinc is what? In which solution? 0.1 molar zinc sulfate solution. 0.1 molar zinc sulfate solution. So which one you have to calculate? Reduction potential. So that's what you write the reduction reaction. If it is oxidation potential, you have to calculate oxidation reaction, you may write. Reduction potential, so that's what you write the reduction reaction. So which one is the reduction reaction? Zinc plus 2 while taking the 2 electrons is going to be deposited as zinc solid. This is which one? Reduction reaction. Reduction reaction. Now, so which one you have to calculate? This one. So what is the next equation? E is equal E naught. If it is cell, half cell, no problem. If it is one half cell means cathode, one half cell and another one is anode, like that. So you can apply that. So E of, I can apply that one half cell zinc plus 2 zinc. So that means E of reduction potential is equal E0 of reduction potential minus 0.0591 by N log K. Log K. K is the equilibrium constant, equilibrium rate constant. Sorry, rate constant. That means here in this case, products concentration by the reactants concentration. So reduction potential is what? Reduction reaction is what? E of zinc plus 2 to zinc is equal E0 of zinc plus 2 to zinc standard reduction potential minus 0.0591 by N. N is how many electrons transfer takes place? 2 electrons. So this 0.0591 I can write approximately that value if it is equal to the 0.06 approximate value. 0.0591 approximately equal to the, I can go to these 3 digits is equal to the 1. That means here it is 0.06. I can increase that digit. So log K. K is what? K is equal to what? Products by the reactants. What is the product? Zinc solid. So, but zinc solid case, I can explain that zinc solid, when it is taken in the solid or excess, that one is concentration which is taken in the unity 1. So this neutral form is taken as the unity. Next, which one is there? Zinc plus 2. By the reactant is zinc plus 2. And zinc plus 2 concentration is how much? He has mentioned that 0.1 molar zinc sulfate solution. 0.1 molar zinc sulfate means in zinc sulfate which one ions are there? Zinc plus 2 and SO4 minus 2 ions are there. Zinc plus 2, SO4 minus 2 ions. So whatever the concentration of the electrolyte solution, ions also same concentration. Zinc plus 2 is also 0.1 and SO4 minus 2 is also 0.1. So based on that, 1 by zinc plus 2 is how much? Concentration is 0.1. 0.1, how to write that? 10 to the power of minus 1. I mentioned very beginning in the quantum mechanics point of view, the limit values. 0.1 if it is there, 10 to the power of minus 1. 0.01 is there, 10 to the power of minus 2, like that. So 0.1 is how to write? 10 to the power of minus 1 or 1 by 10. 0.1 is equal to how? 1 by 10. That is 10 is going to be denominator, is going to be numerator, 10 to the power of minus 1. 0.01 is there, 1 by 100 or 10 to the power of 2. 1 by 10 to the power of 2. That is going to be 10 to the power of minus 2. Now, if it is cancellation takes place approximately, this is 0.03. And this value is how much? E0 of zinc plus 2 to zinc is how much? Which is mentioned as minus 0.76. Right? So, directly I mentioned that minus 0.76. So, this value is minus 0.76. And this is how much? 0.03. And this 10 to the power of minus 1 is there. This is shifted to the denominator, shifted to the numerator, plus log 10. Log 10 value is how much? 1. Log 10 value is 1. When log 10 value is 1, that is equal to minus 0.76 minus 0.03. Minus 0.76 minus 0.03 is there. So how much is that approximate value? Minus 0.79. Minus 0.79 volt. Right. Next, another one more problem. You write that. Next problem. You write the next problem. Standard reduction potential of standard reduction potential of zinc and copper. Zinc and copper is, you may also write that problem, right? Zinc and copper is minus 0.76 volts, comma 0.34 volts respectively. Calculate the E cell. Calculate E cell of following cell notation. E cell of following cell notation. That cell notation is given as zinc sulfate 0.01 and salt bridge is mentioned, double vertical line, CaSO4 0.01 molar concentration and Cu. How to calculate that? If it is given like this, how can you calculate? Now, first which one is given, which one values is given, you read that values. Given values are what? First you read that carefully. Which one is mentioned, which one is you have to calculate. Which one is mentioned? You read that standard reduction potentials of zinc and copper. Both are standard reduction potential values is mentioned. One is zinc, another one is copper. So, this values is given respectively how much? Minus 0.76 volts, comma 0.34 volts respectively. That values will be given. Right? No problem. Then, so Standard reduction potentials of zinc is given as minus 0.6 volts and standard reduction potentials of copper is given how much? 0.34 volts respectively. You calculate E cell of this following cell, E cell. E cell is equal, according to the Nernst formula, Nernst equation, E cell is equal to what? E0 cell. In the earlier one is half cell, reduction of cell, oxidation of cell, like that. Here it is total cell, reduction plus oxidation. So E0 cell is equal, E cell is equal to E0 cell minus 0.0591 by N log K, or minus 2.303 RT by NF into log K, right? So we are maintaining that at 25 degrees centigrade 2.303 RT by F value, which is equal to the 0.0591. Already we can explain in the earlier class. So that's why I can mention direct formula here in this case. Now what is E0 cell? You have to calculate first, then which one is the N value, number of electrons transferred, and which one is the K value, right? In the equilibrium rate constant, rate constant, like that, equilibrium rate constant, rate constant. So the product's concentration by the reactant's concentration, reaction quotient, that is this reaction quotient K is equal to what? Product's concentration by the reactant's concentration. So now here in this case K is equal products by the reactants. Now based on the given two values, which one case reduction reaction takes place, which one case oxidation reaction takes place. So this one case more reduction potential, reduction reaction. That means which one? Cu plus 2 is going to be Cu. I can write the reaction. Or plus 2 electrons if it is there. This first reaction I can explain, plus 2 electrons will be taken. Next, this is less reduction potential is going to be oxidation. That means zinc plus 2 electrons. This one is cancellation takes place. How to write this? Zinc plus Cu plus 2 to zinc plus 2 plus Cu. This is solid, neutral form. This is also solid. Right? This is the cell reaction. From the cell reaction, K is equal to what? Products concentration by the reactants. Now copper solid which is taken in the solid form, is metal, like that concentration will be taken as 1. And this concentration of zinc plus 2 by which one it may be there? Copper concentration of Cu plus 2. So here it is zinc solid also taken, it is 1. So this copper solid, zinc solid which is taken is 1. So then products by the reactant, this one by the this one. K is over. And N is how many electrons transfer takes place? 2 electrons. N is how many? 2. So N is also known that. And E0 cell what? E0 cell is equal. E0 cell is equal. Higher reduction potential minus lower reduction potential. Which one is the higher reduction potential? 0.34 volts minus 0.76 volts minus 0.76 volts. So how much it is there? Highest reduction potential minus lowest reduction potential, or E cathode minus E anode, or E right minus E left. So right side of this all bit is which one is there? Cu plus 2 going to be Cu. So this meaning is what? Cu plus 2 is going to be Cu. This meaning is what? Zinc is going to be zinc plus 2. Like that. So reduction reaction takes place, oxidation reaction takes place. Right? Like that meaning is. So highest reduction potential minus lowest reduction potential, which one it may be there? So so this is 0.34 plus 0.76. How much it is there? 1.10 volts. E0 cell is known that. And zinc plus 2, zinc is going to be zinc plus 2, that means the zinc sulfate means which one dissociation takes place? Zinc plus 2 plus SO4 minus 2. Here it is Cu plus 2 plus SO4 minus 2. That means Cu plus 2 ions are there, and here it is zinc plus 2 ions are there. This zinc is reversible to the zinc plus 2, and this copper is reversible to the Cu plus 2 ion, like that. What is meaning of the reversible I can explain later in the types of electrodes point of view, or further this electrochemistry depends upon the which is reversible to the which ion, either cation or anion, further point of view. So then E cell is equal E0 cell, that is how much? 1.10 volt minus 0.09, that is approximately I can take it as 0.06 in the probabilistic point of view, or approximate value. If it is options will be given, that value is near to the approximate value, very close, not much more changes. So that's what 0.06 I can take. 2 and log K is what? Zinc plus 2 concentration by the Cu plus 2. What is the zinc plus 2 concentration? Is 0.01. So this 0.01 means how much? This is 10 to the power of minus 2, or 1 by 100. This is 1 by 10 to the power of 2, that is 10 to the power of minus 2. So 10 to the power of minus 2, zinc plus 2 by the copper plus 2 is also same. If it is mentioned, the number of electrons are same, transfer the number of electrons, it may be same. Number of electrons transfer or charge, it may be same. Charge, it may be given same. Then concentrations will be same. Suppose this one is concentration and this concentration, if it is same, when this is cancellation takes place, when the concentration of the zinc plus 2, copper plus 2, like that, it may be same based on that number of electrons. Not in all cases, but number of electrons if it is same, and concentration is also same. Whatever this is, log 1 is there. Log 1 if it is there, that value is what? Log 1 value is 0. Log base 10 value is, base 10 1 value is 0. When log 1 value is 0, then this value is 0. This is also complete value is 0. So what will be left? 1.10. Here, if number of electrons are same, that means depending upon the number of electrons, if products and the electrolytes concentration is same, suppose, then E cell is equal to E0 cell. Whatever that E0 cell is there, that is E cell. Not in all cases, it may be deviations or some deviations also there, depending upon the n number of electrons. If n value is also same, that means the reaction charge, it may be same, that it may be easily same, right? So I can explain later. This is the E cell value, 1.10 volts. This is the previous problem, right? Simple problem. Next, another one example. Next, another one type of question. You can also write that question. Standard reduction potential of zinc and silver are minus 0.76 volt and 0.80 volts respectively. Calculate E cell of the following cell notation. E cell of the following cell notation. Here which one is there? Right? So these values will be given, zinc reduction potential, and both are reduction potentials mentioned, zinc and silver. So you can use which formula? E cell is equal to nearest equation, E0 cell minus 0.0591 by n log K. So first, which one you have to calculate? E0 cell. E0 cell, how to calculate? Higher reduction potential minus lower reduction potential, standard reduction potential values. Don't confuse. Higher standard reduction potential minus lower standard reduction potential. Which one higher standard reduction potential is? In these three values, which one value is more? Ag value is more. Ag plus is going to be Ag. How much it is? 0.80. And lower standard reduction potential is how much? 0.76. Total value is how much? This is minus into minus is plus. 0.80 plus 0.76 is 1.56 volt. E0 cell is 1.56 volts. Next, which one is you have to calculate? N is what? Now, What mentioned that zinc plus 2 is going to be higher reduction potential is what? Silver. So from this cell notation, Ag plus is going to be Ag, and here zinc is going to be zinc plus 2. Charge will be different. See, listen. AgNO3 means Ag plus NO3 minus. This Ag plus is going to be Ag. So based on that, reduction reaction is what? Ag plus is taking that electron, is going to be deposited as neutral silver, like that solid, Ag solid, like precipitation takes place. So now here it is, Ag plus is going to be Ag based on this more reduction potential, or based on the cell notation. Cell notation, based on the cell notation, left side is which reaction takes place? Reduction reaction takes place, reduction of cell. Right side is what? Sorry, right side is reduction reaction takes place, cathode. And left side is what? Oxidation reaction takes place, acts as anode. Oxidation of cell, reduction of cell. Right, when we are discussion takes place. So this is happening. And right side is what? Oxidation reaction takes place, or based on this reduction potential also, lower reduction potential is oxidation takes place. Zinc is going to be zinc plus 2 electrons are there. To equalize the relations, that means to balance the equations, so which one you can use? 2 electrons and like that 2. Then what will happen? This is happening. That means zinc solid plus 2 Ag plus is going to be zinc plus 2 plus 2 equivalents of Ag solid. This is the cell reaction. Based on the cell reaction, equilibrium constant, reaction quotient K is equal to what? So products concentration by the reactants concentration. So the solid you can ignore that is 1. This is also you can ignore that is 1 concentration of the two values which is equal to the 1. Then which one it may be there? Zinc plus 2 concentration by the, here it is mentioned like that 2 Ag plus. What is that meaning? Ag plus concentration which is taken as 2 equivalents, then square. I mentioned that earlier, very beginning, A equivalents of A, B equivalents of B, like that is mentioned. How can you calculate that K value? Then it is Ag plus square, 2 equivalents which is there. Now you know that zinc plus 2 concentration is how much? 0.01. That is 10 to the power of minus 2. 0.01 means 10 to the power of minus 2. And this is mentioned as how much? 0.1. Ag plus concentration. So Ag plus concentration is 0.1 means how much? 10 to the power of minus 1. How many equivalents? 2 equivalents. That is equal, which one is there? 10 to the power of minus 2 by 10 to the power of minus 2. That is equal to what? 1. Right? So when log K is 1, this value will be, entire value will be 0. Entire value will be 0. Or you can write that E cell is equal, E0 cell is how much? 1.56 minus 0.06 by n value is how much we can take? 2, because we are balancing the equation by adding that 1 electron, then it is equalization, it may be balancing equation, then it is 2 electrons. So log K, log 1 value, K value is 1, that value is 0. So when that value is 0, which one is there? 1.56 volt. This is 0, entire value is 0, right? So this type of equation will be there. This is also a previous type of question. Previous one question. Right? Next you write that another one more question. You write that. Next question. Standard reduction potentials of E0 of Cu plus 2 Cu is 0.34 volts. And Eg of Ag plus is going to be Ag is 0.80 volts. Calculate E cell of CuCSO4 aqueous of 0.01 molar and AgNO3 Ag 0.01 molar. 0.01 molar. The options also given, but I am not mentioning the options because whatever that it may be there, the problems it may be similar. Whether it is options is also there in examinations point of view. Right? So how to calculate that, you can check that. So you never think that in all times when it is concentrations will be same, that E cell is not E0 cell. Based on the options, E0 cell is also there, E0 cell value is also. But whether you can check them, whether concentrations it may be same, suppose the number of electrons are same or not, you can check them twice before. Like in the earlier one is zinc plus 2, zinc sulfate and CuSO4 Cu case, concentrations will be same, that E cell is E0 cell. But here it is same or not, you can check them. This is also a previous problem, right? Previous question, right? So E cell is equal to what? E0 cell minus 0.0591 by N log K. You write number of times this principle because it may be practicing, right? So E cell, E0 cell, how to calculate that? Higher reduction potential minus lower reduction. By comparing these two values, which one is higher reduction potential? 0.80. 0.80 minus lower reduction potential is how much? 0.34. Or E0 of cathode minus E0 of anode. Which one higher reduction potential acts as? Cathode, reduction reaction takes place. Lower reduction potential acts as anode, oxidation reaction takes place from the cell notation. What is the meaning of cell notation? Right side is reduction reaction, left side is oxidation reaction. Right? So this value is E0 cell value is how much? 0.46 volts. Right? 1 is over. Next N is what? And log K is what? K is what? Right? Now for N value or K value case, what is that meaning of the reaction? This higher reduction potential is reduction reaction, or right side of the cell notation, reduction reaction takes place. This meaning is what? Ag plus is going to be, while taking that electron, is deposited as Ag solid. And right side is one takes place, oxidation reaction takes place, or lower reduction potential oxidation. That means Cu is going to be Cu plus 2, while that 2 electrons is there. So here it is 2 electrons are there to balance the equation, or to balance the charge, or charge will be neutralized. Then only you can add one electron to the second equation. So 2 Ag plus going to be 2 electrons. Then only this will be cancellation takes place. What will be happen? Copper solid plus 2 Ag plus only charged one you can consider. The reactants and products case, Cu plus 2 aqueous plus 2 Ag solid. In the calculation of the constant K value, so the solids you can ignore that value you can take into as 1. So which one it may be there? Cu plus 2 concentration by 2 Ag plus concentration, K is. Now E cell is equal, E0 cell is how much? 0.46 minus 0.0591, approximately you can take it as 0.06 for our convenient point of view. And N value is what? 2 electrons. And log K value is what? K is equal to what? Cu plus 2 concentration. And Ag solid is taken as 1, so no problem. Okay, we don't write that. And here Cu solid also you can take it as 1. Then which one is there? By reactant is which one? Ag plus. How many equivalents are there? 2 equivalents. Like this earlier one. So that's what Cu plus 2 concentration is how much? 0.01. That means which one? 10 to the power of minus 2. And Ag plus concentration is also given how much? 0.01. 10 to the power of minus 2. But how many equivalents? 2 equivalents. So based on that, 0.46 minus 0.03 log, this is 10 to the power of minus 2 by 10 to the power of minus 4. Minus 4. So here it is, takes place 0.46 minus 0.03 into log 10 to the power of minus 2. This is shifted to the denominator, shifted to numerator, plus 10 to the power of 4. This minus is going to be plus. So minus 2 plus 4. Then which one is there? This is going to be minus 2 plus 4. So how much it is there? 10 to the power of 2. So 0.46 minus 0.03 into log 10 to the power of 2. This will be log m to the power of n if it is there. How to write this? N log m. So this power I can write here in this position before. Then which one is there? 0.46 minus 0.03 into 2 log 10. And I mentioned that earlier one, very beginning I mentioned that all logarithm values, so you can check them once, right? At the time of, I can mention some mathematical principles in the quantum mechanics point of view. You can read that, operator's point of view. So then only it will be very easy to know the physical chemistry. So whether you can biological background, so you can read that principles, mathematical principle, nearly 30 or 40 I mentioned that. So that principles we are using, it is very important for the problematic point of view. So then log 10 value is how much? 1. Because every time this values I cannot write, so it is not easy. So then this value is 1, then which one is there? 0.032 into 2 is 0.06. Then which one is there? 0.40 E cell value, right? Next problem, you read that next problem. You can also write that, right, with me. Standard reduction potentials of zinc and silver. Zinc and silver is minus 0.76 and 0.80 volts. 0.80 volts respectively. 0.80 volts respectively. For the following cell reaction, or equilibrium reaction, for the following equilibrium reaction, calculate the equilibrium rate constant. Calculate the equilibrium constant, K equilibrium. Equilibrium rate constant. K equilibrium is what? So option A is given. This is also a previous question. 10 to the power of 26. Option B is given. 10 to the power of 52 approximately. Approximately value is mentioned. Option C is given 1. Option D is given approximately 1.56 volts. So which one is the equilibrium rate constant? So earlier I mentioned that the formula for the calculation of the equilibrium rate constant, you can check the concept, how to obtain that equation also I can explain that in the next equations point of view. Check that last videos, last class. Then what will happen? For the calculation of K equilibrium rate constant is equal exponential factor, or if it is 10 to the power of, because 10 is also mentioned, so that's what not mention any exponential factor. So you can use 10 base 10 to the power of n e naught by 0.0591. N e naught by 0.0591. So this formula I can mention in the last classes. Now which one you have to calculate? What is n value? What is e naught value? What is n value for this reaction? Zinc is going to be zinc plus 2 electrons, and 2 equivalents of Ag plus is deposited as Ag solid. So that means what? By absorbing 2 electrons, by receiving 2 electrons, this one, and here it is by releasing 2 electrons. So that's what the overall reaction n value is how much? 2. And what is E0 cell? E0 cell is calculation takes place. How can you calculate E0 cell? The standard reduction potential values will be given. Standard reduction potential values will be given. For this, based on the standard reduction potentials, you can calculate the E0 cell. Which one? Higher reduction potential minus lower. Ag reduction potential value is more compared to this zinc, or E cathode minus E anode, based on that 0.80 minus of minus 0.76. How much is there? 1.56. Already we have seen, no need to explain again. So minus into minus is plus, that value is 1.56. Then K equilibrium is equal, equilibrium rate constant is equal 10 to the power of N value is how much? 2 electrons transfer takes place for this reaction, and E naught is what? 1.56 by 0.0591, approximately you can take it as 0.06. 0.06. So this type of 1.56 by 0.06, suppose this will be mentioned as, suppose I can write it is 156 into 10 to the power of minus 2, because 2 digits, by 6 into 10 to the power of minus 2. If this cancellation takes place, nearly how many times? 26 times it maybe takes place. So based on this, 26 times. Right? So 2 into 26 is how much? Approximately 52. 2 into 26 is 52. So which one option it may be? Approximately it may be same. So because 6 2 and 3 is there, approximately 26, that means approximately 10 to the power of 52. This is the equilibrium rate constant. Right? This is the problem. You may write the next problem. Next, another one more. In the previous examinations point of view, this type of problems will be given. Next, another one more problem, similar type like this. The examination point of view is mentioned. Read that. For the following cell notation, zinc is going to be zinc sulfate, that means zinc is dissolved in the zinc sulfate, 0.01 molar concentration, and salt bridge is mentioned. The redox couple, that means redox electrode, if it is mentioned, redox couple of Fe plus 2, Fe plus 3. So this is considered as a redox couple. So this is 0.01 molar and this is also 0.01 molar. And for this cell, E cell is equal 1.71 volt. E cell is equal 1.71 volt. And the cell reaction for the above, or the above cell reaction is, zinc plus 2 plus 2 equivalents of Fe plus 3 is in equilibrium with zinc plus 2 plus 2 equivalents of Fe plus 2. Fe plus 2. Calculate the equilibrium constant or equilibrium rate constant for the above cell. This is also a previous problem. Options will be given. Option A is 10. Option B is 10 to the power of 27. Option C is 10 to the power of 54. Option D is 10 to the power of 108. 108. How can you calculate that? So first you read the problem. Which one values will be mentioned? Which one? What you have to calculate? So you know that the problem of the similar one, K is equal to what? Ne naught, 10 to the power of Ne naught by, because all the options are related to the 10 to the power of, not exponential. So that's why you can also use 10 to the power of. Then which one values are mentioned? First you read that. What mentioned that? Concentrations will be mentioned. Cell notation is mentioned. And E cell value is given instead of the E0 cell of E of the instead of the standard reduction potentials of the values, so directly mentioned as E cell value. For the above cell reaction is also given. Why this cell reaction can be used? Right, to know the N value, because based on the problem, so K equilibrium is equal to what? 10 to the power of N E naught by 0.0591. This is the principle. So E naught value you have to calculate. Here it is mentioned E cell value, not E naught cell. E cell value is mentioned. So don't confuse. This is E naught cell, not E naught cell. E cell. Right? Next. N value is which one you have to calculate for this reaction. Based on this reaction, what will happen? Zinc plus 2 is going to be zinc plus 2. Sorry, here it is zinc is going to be zinc plus 2. I think this is the cell reaction. Zinc is going to be zinc plus 2. The cell reaction is given zinc. Zinc is going to be, no, sorry for this, you can correct it. Zinc is going to be zinc plus 2. Cell reaction. Right? This is oxidation reaction takes place, 2 electrons is transferred. Next. 2 equivalents of Fe plus 3 is going to be Fe plus 2. 1 equivalent if it is going to be suppose takes place, 1 electron transferred. 2 equivalents is takes place, 2 electrons. This 2 electrons, if it is absorption takes place by the 2 equivalents of Fe plus 3, then it is converts to the 2 Fe plus 2. So oxidation reaction takes place and reduction reaction takes place. Right? Oxidation and reduction reaction takes place. So based on that, E cell is equal, for the calculation of the E0 cell, how to calculate that? E cell value is given. For the next equation, E cell is equal to E0 cell minus 0.0591 by N log K. This K is not the equilibrium rate constant, is a reaction quotient. So based on that, K is equal to what? Just K is equal to products concentration by the reactants concentration. Products concentration is how much? Zinc plus 2. Next, Fe plus 2 concentration, how many equivalents? 2 equivalents. Square by the zinc solid you can take in this as 1. In the neutral form if it is mentioned you can take in this as 1, and 2 equivalents of Fe plus 3 is there. So that's what Fe plus 3 is going to be square. So log K, directly I mentioned that, or this log K I mentioned that which one? Zinc plus 2 Fe plus 2 whole square by Fe plus 3 whole square. E0 cell is not given. E cell is how much? It is mentioned as 1.71 volts. 1.71 volts is mentioned. And E0 cell is not mentioned. You have to calculate the E0 cell by 0.0591, like you can take it as 0.06, and this is 2. Log zinc plus 2 value is how much? Concentration of the zinc plus 2 is 0.01. Whatever the electrolyte solution, that same concentration will be there, ions also. Minus 2. And Fe plus 2 concentration is how much is mentioned in the redox couple? 10 to the power of minus 2 whole square by Fe plus 3 also similar one. So this one is cancellation takes place. What will be left? 10 to the power of minus 2. That is equal to E0 cell 0.03 into log 10 to the power of minus 2. So this is equal to E0 cell. This minus 2 is going to be here in this position. Log m to the power of n is there. So you can write it as plus, then 0.03 into 03 into 2. 0.06 into log 10. Log 10 value is how much? 1. So this is 1.71 volts. Then E0 cell is equal to how much? This value is shifted to the right side. 1.71 minus 0.06. 0.06. This is shifted to the right side because log 10 value is 1. This is log m to the power of n. N log m. So that's what I mentioned, minus 2 log 10. This it may happen. So how much it is there? 1.71 minus 0.06 is there, 1.65. 1.65 approximately. Why I mentioned that approximately? This is 0.0591 is going to be 0.06. I can take in this. Right, by using this K equilibrium you have to calculate. Then 10 to the power of n value, you know that 2 electrons, E naught value is how much? 1.65 by 0.0591, that is 6 approximately, you can take in it. So that is equal 10 to the power of, this is 165 by, so how can you write that? So 165 into 10 to the power of minus 2 by 6 into 10 to the power of minus 2 and 6 2 and nearly 35 it may be there, nearly approximately 27 times 45 is there. 45 means 26 7 42, like that. So 27 point something it may be there, approximately you can take it as 27. So here it is 2 into, this one is cancellation takes place 27 times. 0.06 into 1.65 maybe takes place. You can write it as 165 into this digits may be exceeding takes place, like that. Left side you can shift that 165 into 10 to the power of minus 2 by 0.6 into 10 to the power of minus 2. Easy calculation point of view. 27 approximately 10 to the power of 54. Which one option is suitable? Option C is the suitable option. This type of problems will be given also in the examinations point of view. Right? Next one problem. Calculate the equilibrium rate constant for the following cell notation. Equilibrium constant for the following cell notation. For the following data. Not mention the cell notation. For the following, E0 of zinc plus 2 zinc is equal minus 0.76 volts. E0 of cadmium plus 2 cadmium is 0.40 volts, minus 0.40 volts. Option A is 10. Option B is 10 to the power of 2, 10 to the power of 24, 10 to the power of 58. Which one it may be there? Approximate values, all this it may be. You know that K equilibrium is equal to what? 10 to the power of Ne naught by 0.0591. That is equal. N value, you know that 2. E naught is which one? Highest reduction potential minus lowest reduction potential, or E cathode minus E anode. Which one is the highest reduction potential? This one. His value is more and this one value is less. Minus 0.40 is more than the minus 0.76, which is close to the 0. So now E0 cell is equal to how much? E0 cell is equal minus 0.40 and minus of minus 0.76. So how much it is? Minus 0.40 plus 0.76. How much? 0.36. By the 0.0591 is approximately, you can take it as 0.06. 0.06. How many times it is takes place? 6 times. Or you can write this is 36 into 10 to the power of minus 2 by 6 into 10 to the power of minus 2. So minus 2 is cancellation takes place. 6 36. So that it may be how much? It may be there approximately 10 to the power of 12. Approximately it is 10 to the power of 12. Right? Next similar type of problem, last problem of this following type. Next one is calculate the equilibrium rate constant. Similar one. Calculate K equilibrium for the following reaction. E0 cell is equal 0.295 volts. Which one is there? If it is given like this problems, you have to calculate. So what is that? How to calculate that? What is the principle is K equilibrium is equal 10 to the power of n E naught. N value is how many electrons? A is going to be A plus 2, B plus 2 is going to be B. That means how many electrons transfer? A is going to be A plus 2 is 2 electrons, and the 2 electrons will be taken by the B plus 2, then B it may be there deposited. So that's why N value is 2 and E naught value is how much? 0.295 by 0.0591 or 0.06. So 10 to the power of 2 into this value is very close to the 0.3 or 0.30 something it may be there. 295 it is going to be 3 or 30 or 300 whatever it may be you can use. And this is 0.06 approximately. How many times going to be takes place? 5 times. Or 30 into 10 to the power of minus 2, right, by 6 into 10 to the power of minus 2, that it may be 5 times it may be there. So how much it is there? 10 to the power of 10. This is the option. Suitable option is like this, right? Next, another one more of the previous examinations questions. Previous questions. You write that question. Which of the following one is correct relation? Which of the following one is correct relation? Correct relation. Oxidant O plus N electrons is going to be reductant. O plus N electrons is going to be reductant R. Option A, E is equal E naught minus RT Ln oxidant by reductant. Concentration B. So just it is mentioned like this, O plus is going to be reductant. Next, option B is oxidant by reductant is the concentration is equal E to the power of minus NF by RT into E minus E naught. Option C, oxidant concentration by reductant is equal E to the power of NF by RT into E minus E naught. Option D is, this is the relation, right? NF by RT into E plus E naught. Which one is the correct relation? That is the question. Which of the following one is the correct relation? In the next equations point of view. So how can you solve this? Right? So just to apply the next equation. The problem based on this problem is, overall problem is next equation is applied for this reaction. So next equation is what? E is equal E0 cell or E0 half cell or whatever it may be. E0 cell minus RT by NF. Ln is given. If it is 2 log is given, 2.303 RT by NF. If at 25 degrees centigrade or something, it may be given 0.0591 by N. If it is problems will be given. So if it is Ln is given, so you can apply Ln. K value is what? Reductant by products concentration by the reactants. That means what? Reductant by the oxidant based on this. So the first one is not there, RT by NF is not mentioned, and oxidant by reductant is mentioned. So this is not right option directly. So based on these three you can check them. Based on these three which is related to the oxidant by the reductant concentration. So that means this one point of view we can focus. So that means if it is shifted to the right side, what will happen? E minus E naught is equal minus RT by NF Ln reductant by the oxidant concentration. And this one is equal Ln R by O is equal. This is also shifted to the right side. R minus Ln R by O is equal. This RT by NF is shifted to the right side. NF by RT E minus E naught. Then which one particularly? Oxidant by the reductant. So that's what these two are interchanging takes place. This minus is going to be plus. So oxidant by the reductant. So this is interchanging takes place. Again minus is there. Already minus is there. Minus into minus is plus. This side is, it may be similar. E minus E naught. Then oxidant by the reductant is equal. This Ln is going to be right side exponential factor. If it is log is there, that is 10 to the power of like that. So exponential factor NF by RT into which one? E minus E naught. Which one option is suitable? Option C is the suitable option. This is a 4 marks question of the earlier previous examinations question. The previous examinations question, 4 marks question. Right. Next, another one of the previous question, you write that. For the half cell reactions, for the following half cell reactions, the reactions are Cu plus 2 plus 1 electron is going to be Cu plus E0 cell value. E0 value is E0 cell is E0 of the standard reduction potential is 0.15 volts. Such that value E0 value, standard potential value, either reduction or oxidation, we can check them later. Next, second one, Cu plus 2 while taking the 2 electrons is going to be Cu solid. That E0 value is 0.34 volts. Calculate the E0 of half cell reaction of the half cell reaction of Cu plus 1 electron is going to be Cu solid. Option A is given 0.53 volts, minus 0.53 volts, 0.83 volts, minus 0.83 volts. How to calculate that? Based on the given data, you can calculate that. So how can you calculate? What is mentioned, which one you have to calculate? First you read that problem. See, listen, you have to calculate this one. Earlier I mentioned that if A to B takes place and B to C another one reaction takes place, and A to C if it is direct reaction is given, how can you calculate that formula? I mentioned that. In the case of the Nernst equations point of view, I mentioned that the formulas. So you can check that. That formula is also mentioned. I can. So this reaction will be generated. The final option is based on the given two values. How can you solve? So what is that? Cu plus is going to be Cu. This one is obtained based on these two. So first one Cu plus 2 is there, this is also Cu plus 2. But here in this case left side is what? Cu plus is there. That Cu plus is here in this position is there. So for this, which one is mentioned? So 0.15 volt is there, 0.15 volt, right? For this reaction, that is E0 value, when it is reverse takes place in the equation 1, that is it may be going to be Cu plus is going to be Cu plus 2 plus 1 electron. This is reverse of this reaction takes place. Why? Because reaction, the final reaction is what? Cu plus is going to be Cu solid. That it will be obtained. So that's what Cu plus 2 here in this side is there, then it is reverse takes place, this will be obtained. So when it is E0 cell is before is what? 0.15. If cell reaction should be reversed, that value is also reversed. That value is also minus, you can add. Minus 0.15 volt. Plus is going to be minus. Next. For this reaction, so in this right side it may be, what is that product? It may be Cu solid. So this it may be there. So that's why we can write this second equation is as it is Cu plus 2 while 2 electrons is going to be Cu solid. So it may be same reaction. So that's why E0 is also 0.34 volts. When this 1 electron is cancellation takes place, the 1 electron is left. Right, then which one it may be there? Cu plus 2 is also cancellation takes place. Then Cu plus 1 electron is going to be Cu solid. This reaction will be generated. Right, now what is the E0 value? How to calculate that? For this E0 cell is what? Sorry, E0 is what? I mentioned that earlier one. If A to B takes place and B to C takes place, directly A to C for what? I mentioned that. So based on that, earlier I mentioned that for the calculation of the E3 naught is equal N1 into E1 naught plus N2 into E2 naught by N3. You can check this formula, I mentioned that very beginning. So no need to explain that. A to B is there, B to C is there, directly A to C is what? So this is A to B and B to C, and A to C is what? Cu plus 2 Cu is what? So then E3 naught or this one is equal, N1 is first electron, first case how many electron transfer? 1 electron into E1 naught is how much? Minus 0.15 plus, in the second case how many electron transfer? 2 electrons into how much it is there? 0.34. Because while 2 electrons transfer takes place, then only copper solid is deposited. Right? This one case, 2 electrons transfer takes place. Don't confuse 1 electron. So cancellation takes place, then only 1 electron. But before that reaction is 2 electrons. So N3 is how many electrons? Here in this case, 1 electron. This is first reaction case, second reaction case, this is third one. How much it is there? Minus 0.15 plus 0.68 by 1. How much is there? 0.53 volts. Option A is the correct one. Right? This type of reactions problems are there in the previous exams, previous examinations point of view. Right? Another one more, last one I can explain. Another one more. Last one problem. Or similar type of problems is there, I can explain when the next classes these problems will be explained, which one it may be there. Next another one more problem, similar like this in the previous problem. The ratio of composition of, you may also write the problem, the ratio of composition of oxidizer and reducer species in electrochemical cell, oxidized and reduced species in electrochemical cell is given by e to the power of 2 exponential factor 2. The correct potential difference will be the correct potential difference will be option A is equal E minus E naught is equal 2RT by NF. Option B, E minus E naught is equal minus 2RT by NF. And C is equal, option C is equal RT by NF, and D is equal E minus E naught is equal minus RT by NF. Here we have imagined the reaction in the earlier one I mentioned that the same problem, that type of reaction will be there. That reaction, it may be oxidant, n number of electrons are there, that is going to be reductant. So that is the earlier problem I mentioned, that similar one it may be there. This reaction is also similar like this reaction is mentioned. And for this reaction is mentioned that relation is oxidant by reductant is equal to the reduced species. The ratio will be given e to the power of 2 exponential factor 2. For this, E cell is equal, or E is equal to E naught minus RT by NF Ln, which one? Reductant by the oxidant, like in the earlier one problem. For this, if this is shifted to the right side, E minus E naught is equal what? Minus RT by NF L and reductant by the oxidant. But what mentioned that oxidant by the reductant value is mentioned. So if it is denominator and numerator is interchanging takes place, what will happen? Again minus is there, already minus is there, minus into minus is plus. So Ln oxidant by the reductant. If it is interchanging takes place, minus is addition, but already minus is there, that is going to be positive. And Ln means Ln base E exponential. Log if it is there, log base 10, whatever it may be, that value is given 1, 2, 3 r. So Ln if it is given, base E is there. And log base 10 value if it is there, that value is 1. So similarly, Ln base E is there, that value is 1 in mathematics. Right? So similarly here it is, Ln means exponential factor E. So RT by NF Ln, this value is what? Exponential E square. Already base E, this value Ln. So that is equal log n log m type if it is there, or Ln m to the power of n Ln m. So this 2 is, I mentioned that here in this position, 2 into Ln base E, that value it may be 1. Or if it is like this value, it may be 1. So this value is 1. So how much? That is 2RT by NF. E minus E naught is equal 2RT by NF. Option A is the correct one. Option A is the correct one option. Right? So next one problem, you write that next one problem. This is also previous problems. Previous questions are there. The standard electrode potentials of standard electrode potentials of, as not mentioned specifically reduction or oxidation, mentioned as standard electrode potentials of Fe plus 3 by Fe plus 2 is equal, and Fe plus 2 by Fe are plus 0.77 volt and minus 0.44 volts respectively at 300 Kelvin. The standard electrode means 25 degree, 27 degree centigrade, or it may be 25 degree centigrade, or it may be mentioned as 300 Kelvin. Right, plus 273 if it is addition takes place like that. At 300 Kelvin, the E0 of that means standard electrode potential of Fe plus 3 by Fe is how much? Option A is 1.21 volts, 0.33 volts, minus 0.11 volts, minus 0.04 volts. Approximate values, all these are. So how can you solve this? I already explained this type of problem. How can you solve this problem? So first one is what? Fe plus 3 is going to be Fe plus 2. How many electrons while taking takes place? 1 electron is going to be Fe plus 2. Fe plus 3 charge is reduced to the Fe plus 2. That means how many electrons? 1 electron is absorption takes place. Right? How much? E0? 0.77. Next, Fe plus 2 is going to be Fe. Fe plus 2 is going to be Fe. Charge will be neutralized. How many electrons is absorption takes place? 2 electrons. Then only Fe is obtained. How much E0? Minus 0.44 volts. For which one you have to calculate? Fe plus 3 is going to be Fe. So you have to calculate which one? Fe plus 3 is going to be Fe. Fe plus 3 is going to be Fe. How much electrons it maybe takes place? 3 electrons. E0 is how much? This E0 is how much? You have to calculate. Right? So by using these two reactions, if it is third one reaction is generated or not, so you can check them. So if it is cancellation takes place, Fe plus 3 electrons is going to be Fe. Right? So by using these two, this one is generated. This is A to B and B to C, then A to C reaction type. Right? So then E3 naught is equal to, suppose this is E1 naught, E2 naught, E3 naught. E1 naught is what? N1 naught is how much? N1 naught is 1 electron into E1 naught is 0.77 plus N2. N2 is how many electrons? 2 electrons into E2 is how much? Minus 0.44 by N3 into E3 naught. N3 is what? 3 electrons. Which one formula you can apply? N1 into E1 naught plus N2 E2 naught by N3 for the calculation of E3 naught. This one. Suppose this one E1 naught, this is E2 naught, this is E3 naught is how much? You may imagine like that. So how much? 0.77 minus is there, minus 0.44 into 2 is minus 0.88 by 3. This is approximately equal to the 0.11 minus 0.11 by 3, approximately equal to the minus 0.04. This one approximately minus 0.11 is there, so that's why 0.04 approximately, or 0.39 something it may be there, that it may be going to be 0.04. Right? This is the previous one problem again. Next, another one type of problem, similar type of problems are there. Or previous problem. So you may expect definitely from the nearest equation point of view, question is there. Right? Either it may be 2 marks or 4 marks is not mentioned, but question is there, but most chances for the 4 marks question. Most of the cases 4 marks question. Next question. This is a 4 marks question of the earlier examinations. The correct value of E naught of a half cell, E naught of a half cell E naught of a half cell. In the following graph, of E versus log M, where M is the molality. M is the molality. M is the molality. The graph is correct value of E naught of a half cell in the following graph of E naught. The graph is in the y-axis is E log M A, B, C, C dash and B dash. Option A, C dash by AC dash. Option B, AB dash. Option C, BB dash. Option D, C dash. Which one is the correct one? It may be there. So which of the following one is correct? How can you calculate that? You can calculate so this type of graph will be obtained at which one case? Right? In the oxidation half cell case or reduction half cell case? Reduction half cell case, we have been observing this type of graph. So E is equal, according to the nearest equation, E naught minus RT by NF ln K. If it is the molarities will be taken, this type of graph is which one? Or if it is any one graph in this position, product concentration by the reductants concentration, products concentration by the reactants concentration. And this type of similar graph I can mention for this one case. M plus N is going to be M, reduction reaction case. So here it is, M plus N is going to be M, E0 of M plus N is going to be M, minus RT by NF, ln 1 by M plus N type. This is shifted to the right side. Which one is there? E0 of reduction potential, because standard electrode potential is reduction potential. Minus, so if it is shifted to the right side, minus is going to take place. This is going to be plus RT by NF ln M plus N. This concentration is in terms of molarity. So this is happening. The plot between this one already I can explain, right? So the plot between y-axis is what? E, x-axis is what? ln M plus N, the concentration of the species, and C is intercept. This intercept C is equal to what? E naught, and slope is RT by NF. So by extrapolating this type will be happen. So this area will be what represents? E naught. Intercept is E naught. In any one case, intercept is E naught. Either it may be this type of graph or this type of graph. The intercept which is equal to the E naught. Intercept is the E naught. So which one it may be the intercept? B dash. The plot between E log M, which one is there? Intercept is the E naught. Right? B dash is the intercept. Right? So this is the previous one problem will be mentioned. Right? Another one more of the previous problem. This type of similar one it may be there. Another one more of the previous. for the cell reaction, for the following cell reaction or cell reaction, tin solid plus Sn plus 4 aqueous to 2 equivalents of Sn plus 2 aqueous. Separate electrode reactions would be written. Separate electrode reactions would be written. With the respective standard electrode potential data. With respective standard electrode potential data at 25 degrees centigrade. So because at 25 degrees centigrade and 1 molar concentration, this will be considered as an standard electrode potentials. So values will be mentioned. Sn plus 4 aqueous plus 2 electrons is going to be Sn plus 2 aqueous, Sn plus 2 aqueous plus 2 electrons is going to be Sn solid, and here E naught value, first reaction is mentioned 0.15 volt, and second reaction E naught value is minus 0.14 volts. When RT by F value is given as 25.7 millivolts, 25.7 millivolts, logarithm of equilibrium constant log log ln k value. Ln k within the bracket is mentioned. Ln k is option A 22.6, option B 226 volts, option C 2.26, option D equilibrium rate log k value is what? 2.26 into 10 to the power of 4. So how can you calculate that? Which one is given, which one is you have to calculate. That is the problem. Which one we have to calculate? The logarithm of the equilibrium constant, like that ln k you have to calculate. What is mentioned that ln k you have to calculate that. Right? That means E is equal E0 cell minus RT by NF. Ln k is what? Mentioned like that. Ln k is what? So you don't go for the products concentration by the reactants, not it may be there. For this reaction, E0 cells will be given. This is one E0 cell and this is another one E0 cell. The given E0 cell values are reduction potentials or not. You have to identify that. While taking the 2 electrons, reaction potential, this is also the reduction potential because reduction reaction. You don't go for this reaction. With the changing of the reactions or not, this is not a matter, because this reaction is not calculating the K value. Directly mention the ln K value. So no need to explain, no need to write that E3 naught is what for this reaction is not asking. Right? If it is E3 naught is what for this reaction, you can interchanging of these two equations by generating this equation. But it is not happen. So law ln K is what? It was mentioned that. So that's what. Both are reduction potential values are mentioned. So then E0 cell is equal higher reduction potential minus lower reduction potential. Higher reduction potential is what? 0.15 minus lower reduction potential is 0.14. How much this is? 0.29 volts. And RT by F value is mentioned. How much RT by F value is mentioned? 25.7 millivolts. That means into 10 to the power of minus 3 volts. 1 milli is equal to 10 to the power of minus 3. Right? This is happening. Next, E is equal, E naught is equal E naught now here it is mentioned as equilibrium. Equilibrium is mentioned. So for equilibrium reaction is mentioned specifically E cell will be 0 because delta G is equal 0, E cell is 0. E cell is 0. When E cell is 0 for equilibrium type of reactions, then E0 cell is equal RT by NF ln K. RT by F NF ln K. Right? Already you can discuss and explain in the earlier case also similar like this. E naught is equal delta G naught is equal minus RT ln K, and delta G naught is equal to what? Minus NF E naught, then minus RT ln K. This principle also we are using, and this one is cancellation takes place. E naught is equal to what? RT by NF ln K. This principle also we have been using. In the next equation point of view, I already explained that this one, similar one it may be there. And RT by F value is how much? 25.7 into 10 to the power of minus 3. By N value is how much? How many number of electrons transfer takes place? 2 electrons. And ln K, this value is how much? 0.29. Then ln K is equal to how much? 0.29 into 2 by 25.7 into 10 to the power of minus 3. Nearly this is how much? 0.53, 0.58. This is shifted to the right, denominator shifted to the numerator, 10 to the power of 3. 0.58 into 10 to the power of 3. That it may be nearly how many times it may be takes place. That is 0.58 into 10 to the power of 3. That means here it is 580, 1.2 points. So it may be going to be 580 by how much? 25.7. Nearly how many times it may be takes place? 22.6 times. Not 226, not 2.26, not 2.26. Which one? 22.6. This formula you can use because equilibrium is there. Delta G is equal to 0, equilibrium. Then relation is delta G is equal to delta G naught plus RT ln K. I explained in the earlier one. Based on this only we have been obtained the next equation. From next equation, E cell will be 0 when it is in equilibrium, or delta G is equal to 0 when it is in equilibrium. This one will be happen. Right, whatever it may be, you can use the formula. So this type of problem is also given in the previous examinations point of view. Right.